2, 1, welcome in. So equation or equations of a plane. So there's different ways of being able to represent a plane in 3 dimensions. Now my assumption is that you're very familiar with lines and how to represent lines. So either in y is equal to mx plus b form, which is the slope and intercept form, or the standard form, or sometimes called the scalar form, and also the parametric or vector, okay, equations of lines. So if you're familiar with those, okay, that's going to help so that you're going to have a good source of fundamentals to be able to tackle this. Now, if you've missed any of that and you wanted to be able to learn about those equations of line, I'll put up a link up above there. Now, in this video, I'm going to just restrict myself to really the standard form, or again, it's sometimes called the scalar form, depending on which textbook you read, and then which mathematicians or sometimes scientists are talking about this. So if you take this form, so you can have it either in the ax plus by plus c z plus d is equal to 0, or sometimes the d is going to appear on the right hand side. So that's what you see there on the left hand side right below there, okay, in green. Now on the right hand side of the screen, so you're actually seeing CPM 3D plotter. So I have used math3d.org, which is a great tool, and I'm very thankful that they put it up and it's free online. So here's another one, so you can certainly search this one. So I'm going to try it out in this video and see how it works. And the goal is to try to make things visual for you so that you can see how these particular planes can be plotted within the X, Y, and Z actual axes. So I have plotted 2 of actual planes in here. So the green one that you see and then the blue one. Now, of course, these extend for an infinite amount, okay, of space unless you start to restrict them and you put restrictions like you sometimes put restrictions on maybe functions. So, as you can see here, so I have a plane right there, which is green, and then I have a blue, okay, which is showing right in, and they do intersect at a particular line, as you can see there. And then the blue just comes out. And of course, this just depends on where you're looking at this. So you can look at it from the top, right, from the bottom, right, so how this looks like. So I really do like this particular tool, which CPM 3D plotter, okay, has provided. So this is just for educational purposes in here that we have. So I'm going to come back to this in just a moment, but let me talk about these actual planes and how do we come up with these particular formulas, or at least for the moment is how do we take the actual formula or the equation of the plane and how we can find numerous things from it. So for example, like the x-intercepts, y-intercepts, and now we have to worry about the z-intercepts as well. So those ones are going to be the third one that we're going to be trying to figure out. So if you take a step back 2 lines and you recall, so not necessarily maybe the vector or parametric equations, I want to leave those on the side for the moment, it's not part of this video, but I want to go back to those, the standard form or the slope y-intercept form. And in particular lines, as you were thinking about those, so let's say if you had a line which is maybe, let's say 2x, minus y, and let's say this was equal to maybe 10. So if you wanted to be able to talk about this was in 2 dimensions, it was relatively simple to be able to try to graph this. And from here, when this is kind of can take on any form, this would have been just ax, okay? So in this right here would have been our by, so in this case the b would have been -1, and then this would have been equal to c. And this is the standard or the scalar form that we would have. And then from this form, we can certainly graph this. Now, we can change this also to the y is equal to mx plus b form, which is my kind of favorite to be able to graph. I have a lot more intuition into that than I actually do into the standard form because it's not as used as often, or at least it's not as used as often for myself. Maybe it's used quite a bit by others. But if you wanted to be able to plot this, a very easy way, you don't necessarily have to transform this. You can just find the x and the y intercepts, right, by just plugging in zeros. So for example, if you wanted the x-intercept right here, what we can do within here, so that means we would set our y is equal to 0. So that would allow us to find, so this would have been 2x is equal to 10, and then, you know, this would have been giving us x is equal to 5. So our x-intercept would have been just simply 5, 0. If we wanted to find our y-intercept right here, so we would just simply take on, and in this case, set the x is equal to 0. And if we do that, we were going to get negative y is equal to 10, or simply y is equal to negative 10. So that would have been our 0, negative 10. That would have been our y-intercept. And then from here, we can certainly plot the line rather quickly, right? So I can just draw this line in fast-forward fashion. So here's the line, and you know, I just plotted it up. I basically just put in the intercepts, the 2 points, and drew a line through it, and it's rather easy to be able to see this. Now, what happens, right, if we take this extension of our line in standard form, and then we start plotting it out into, you know, the third dimension? Now, we can't actually extend, you know, this right here and say that, okay, well, now we can take a x plus b y, and then we can say, okay, well, what about instead now call this c z is equal to d. Now, if I would do this right here, okay, and I would try to figure out that this is going to be a line, well, I would have been mistaken. So this actually would plot out a plane for me in 3 dimensions. And this is a little bit tricky because you are so used to using this right here and then thinking about this actually giving us a line. But in 3 dimensions, when you do take the standard form or the scalar form, whatever it is that you want to call it, you are going to get a plane. And now this particular plane, okay, that you would have is indeed going to take on kind of an infinite plane depending on what the values of a and b and c and d are. So you can take all of these, okay, and then try to see. Now, let's make it very simple in the beginning. So for instance, if I would take this and I would set, let's say a is equal to 1, so I would get just 1 times x, so I'm going to get x. And let me make all the other ones simply equal to 0. So let's say I'm going to actually just write this out just so that you can see it right directly how this would be. And let's say d, you know, maybe I'll make it equal to 5. So if I do this, now of course if I simplify, then I'm going to just get x is equal to 5. Now if I was thinking in terms of x is equal to 5 when it was a line, right? So if I wanted to plot this right here, well, that would have been easy. You know, you would have just simply gotten a vertical line which would have went all the way up. And that's why, so the reason for that was because we can take on any values for y, and so long as x is equal to 5. Now, when you extend this to 3 dimensions, you are not only going to be dealing with allowing y to be anything, you also can now allow z or z to be anything. And so now the y and z all of a sudden, so those are kind of 2-dimensional, and now the x makes it 3-dimensional. So what this would actually tell us is that we will fix and always have x is equal to 5. But y and z can take on any value we like. And, you know, if you would plot this out, and if you had this in 3 dimensions, then this is what you would get. Now, what I can do is, okay, so with that x is equal to 5, I would actually get a plane, and this particular plane would cut right through. So now notice, because the y that I have in here is really horizontal, or at least I made it horizontal, okay, within here. So what I would have is this particular plane as I would go through this. So if it was only in 2 dimensions, you know, so we knew that this would have been kind of going off into infinity in this way, and then also going off into infinity that way. right? So that is my line. So that's like my vertical line there. But I also now have the z, right? So the actual coordinates, okay, of the z to go up. So now this is also going to be extending, okay, itself upwards, okay, within here. So it's also going to go up, and it's also going to go straight through, okay, so this particular 5. Let me align this properly. I hope I can do it. So here I can kind of shift it as much as I can, okay, so right on there. And now I have, you know, my y and my z taking on anything I like. And this is going to just take on now an actual plane that I have in here. So that particular plane, you know, it's going to go off, okay, into infinity in all directions, okay, kind of up and down, right? So it's going to be centered around x is equal to 5, and it's going to go on everywhere. And this is actually what I drew out, and this is one of the actual planes. So if I go back in here, okay, so let me actually remove the other one, and I'm going to just show you. So this is the actual plane, okay, that I have. So notice that I have x is equal to 4. So I know it might be a little bit hard to see. You can look on the left-hand corner there. And then, so I'm going to set this one, we have 5 there. So that's not that it really matters, okay, if it's 4 or 5, but let's make it 5. So now in here, notice that this particular plane, right, so it cuts through. So notice it goes through in the y, okay, and then it goes all the way up in the z direction as well. And so this is looking from the other side, okay, and from the top. So that's how that plane would actually look like. And that's pretty neat to be able to, you know, see it in this particular way, right? So that at least in this way that we would have it. So with this, you know, we can extend this to, of course, other planes. It doesn't necessarily have to be a simple plane like this. We can, you know, have all kinds of different planes. Notice that this only has one intercept on the x, right? It doesn't intercept the z axis, and it doesn't intercept the y axis either. Now, if you would continue with this, you know, you can certainly start extending these things out and making these more complicated for yourself. So if I would, for instance, take on, so this is my ax plus my by plus c times z is equal to d. Again, the d doesn't matter if it's on the left or on the right. You can, of course, just shift it as you like. And now, let's say that I wanted to make this, you know, let's say I do have a is equal to x, and then I'm going to make my b is equal to 1 as well, although it doesn't have to be. And then, you know, I still make this particular c0, and let's say, you know, I still keep it at 5 over here. So now, if you think of this, you know, and if you wrote this out, x plus y is equal to 5, you might think that this is a line, right, for yourself. So you're like, oh, x plus y is equal to 5. I can move the x on the other side, and I have y is equal to negative x plus 5. So now I have a slope and a y-intercept, and you know, I can plot it. But if someone tells you that this is in 3 dimensions, then it's not going to work that way. Because in 3 dimensions, now all of a sudden, the z, which is not present here, right? So you have a z, and it can take on any value. So this particular z can take on any values that you have. And because your c right here is set to 0, so no matter what the value of z is, then it's still going to be 0, right? Because 0 times any value is going to be 0. So it's not going to change this particular equation, and it is a plane equation. It's not a line equation. And that is tricky. So now you might start thinking, okay, well, how am I going to start plotting this out for myself, right? Now, I can certainly do so, you know, if I have a tool, and I can pop up the tool, and I'm going to do that again. So it's x plus y is equal to 5. So let's say I add another plane in here. And in here, you know, I can change this. So we said the A is 1, the B is 1, the C actually is 0, and then we're saying that this is equal to 5. So this is what we have there. And I'm going to just hit this. And now all of a sudden, so notice what happens in here. So as you're kind of going through, okay, so this particular plane, okay, that you have in here, notice that it crosses the x and the y. Now you might see that, okay, within. So there's actually these 2 points there that you have. It, you know, it crosses that other plane, that the green one. So this one is purple within here. But notice that it is parallel to the z, right? So it goes straight up. And it is parallel to the z-axis there, okay? That's the one that we have showing. So I'm going to try to shift it around a little bit, okay, in here, just so that you can see it from various angles. So that is my plane. Now, how would you have actually drawn this yourself? And one of the nice thing is, at least what I think about in terms of trying to plot these out, and then of course what others think about as well, this is not just me, but if you're going to be plotting something like this out, I highly encourage you to take, when it is in this form, when it is in the standard form or scalar form, then I encourage you to find the x, the y, and the z intercepts if they exist. Now, in the first example, so in this example, we only had an x-intercept, so that was right there. And then if the other ones were zeroed off, so we just know that we have a plane which is just vertical. And basically, okay, it's just parallel to the y and the z axes. Now, if you shift over and you have something like this, the x and the y and the z is zeroed off. So it's going to be parallel to the z axes, but you are going to have an x and a y intercept. So what about these intercepts in general? So, you know, how do you find them when we do have this particular form of a line? So I just want to tell you how to do that. And I also would like to point out that if you do have it, you know, you can certainly then start plotting this out as well. So to find, for example, the x-intercept, what we like to do, now whenever we were doing lines in 2D, we would set y is equal to 0. Now, because we're in 3 dimensions, we don't just set y is equal to 0, but we also will be setting our z is equal to 0, because now we're in 3 dimensions. And now if you do that, let's say if I do this example for this, then what you're going to find is this is going to be just x, you know, the y is 0, so this is going to be x is equal to 5. So my intercept is going to be the point 5, 0, 0. Now, if you wanted to be able to find the y-intercept in here, so what you would do instead is, like for lines, you know, you're going to set x is equal to 0, but you also are going to have to set z is equal to 0, because now you're in 3 dimensions. And if you do that, and again, if you plug this back into, you know, this equation, or standard equation that we have there, well, the x is equal to 0 is going to just leave us with y is equal to 5. So now my y-intercept is going to be 0, 5, 0. And those are going to be the 2 points that I have. And now notice, if you wanted to find your z-intercept in here, then what you would try to do, you're going to try to set x is equal to 0 and your y is equal to 0. Now, of course, for this line, if you do that, you're going to get 0 plus 0 is equal to 5. And this, of course, so 0 clearly doesn't equal to 5, so it doesn't exist. So what that tells you is that the z-intercept simply does not exist. That's what the idea would be in here. So if you find that for yourself. And of course it doesn't exist because of the fact that c is equal to 0. And in this case, what we have is we just have a plane which goes through those points. Now, if you were plotting this out, okay, in 3 dimensions, I just want to show you how you can do that. Now, I'm going to borrow this actually from here. So let me copy this and bring it down for us. So if this is the case, so what you would do is the following. Now, of course, if it's all numbered, then it's great, but you just simply plot out. So this is going to be, if this is your x-axis, this is your y-axis, this is your z-axis. So this is your 5, so you have your intercept right here. That's that point. And then you plot out your y-intercept. So, you know, let's say that this was 5 on the y-axis. Now you have both of them there. And really what happens is now you join them right here. And then you make a vertical. So you're going to be going up because of the fact that you are parallel to the z-axis, right? So as you extend these through, you know, maybe further, okay, as this keeps going, okay, this is going to now create a plane. You know, that plane, okay, is going to be going straight up. And then sometimes what we like to do is as we draw this out, you know, we just actually draw this. Let me extend this back down. So below the XY plane, so it looks like it cuts through, right? And then it goes straight up. But of course it extends in all kind of infinite, okay, directions in here. But it's just a plane, which is parallel to the Z-axis. So that is great to be able to do that. And that's exactly what has happened. So notice right here, I mean, this obviously is much nicer to be able to see that in 3 dimensions over here. Now this is how they have drawn it out, okay, for this. Let me remove this one so that you just only see this. So here it is. Now I'm spinning it around, not exactly in the best way. Okay, so this is what you would have right there. So I'm just tilting it back and forth. Okay, and notice that it goes up and it's parallel to the z-axis, although I'm spinning these z-axes, you know, a little bit too much here. So that is how you would try to plot these out. And then you would find these x, the y, and the z intercepts. And you can do that for really anything that you have. So now, if I would show you another example, for instance, so within here, and let's make it now, I don't know, let's say maybe 2x. I'm honestly just making this up now. 2x minus y plus 3z, you know, is equal to, let's say maybe 4. And this is now my actual plane. So it is in the form of ax plus by plus cz is equal to d. And I can actually find out what that a, the b, and the c is. And now if you wanted to find your x and y intercepts, the z-intercept, again, you would just simply go, all right, so I know that I'm going to have to set y is equal to 0. I'm going to have to set z is equal to 0. So you always set 0 to the opposite of what you're trying to find. So if you're finding the x-intercept, it's going to be the y and the z that is set to 0. And now notice what's going to happen is you're going to get 2x. The other ones get zeroed off. And then so from here, you're going to get x is equal to 2. So this is going to be 2, 0, 0. That's your x-intercept. And now you can plot that point, right? So you would already have it. Now for your y-intercept, if you wanted to find this one, then you would set, so y-intercept, that means x is going to be equal to 0 and z is going to be equal to 0. And if you set that through, you're going to get negative y is equal to 4, which is going to give you that y is equal to negative 4, or that your intercept is 0, negative 4, 0. So now you have another point. Now notice this one is on the negative side. So within here, I would actually have to try to extend this out, okay, further, okay, in the negative direction there, if I was plotting this out in here. So let me do that. I'm going to actually remove these so that we don't have them anymore. And then we're going to try to plot this out. So I have, okay, the points, maybe I'll put it in green, in here. So 2, 0, 0. So let's say maybe it's somewhere over here. Let's say that's a 2. It's on the x. The y-intercept is 0, negative 4, 0. So it's going to be a little bit further. So that's going to be, you know, negative 4 over there. So now I have 2 points. And now I can connect these together, right? So this is how I would try to plot it out. But this would be just a line, and I am going through a plane. So now I also need my z-intercept. Now in this case, notice that the c is not equal to 0. So in that case, if I'm going to do this, I have to set x is equal to 0. I have to set y is equal to 0. And if I do that, now unfortunately I'm going to get 3z is equal to 4. So this is going to be that z is 4 over 3. And for this one, so it's going to be 0, 0, and I guess 4/3. So that's what I would have over there. And if I would do that in here, let me go back to the green. So it's going to give me, 1 and 1/3. So it's not going to be too far up here, but it's still going to be on the positive side. And the way that you would do it is you would just simply connect it. So notice the connection through that you would have in here. And now that's the plane, and that plane would obviously go straight down and then go up as well. And it would just go and span out the entire thing. So now I'm going to try to plot it out on our tool in here. So if I do that, so let me add another plane and let me add all of these. So now notice how nice this is. So this is going to be a 2. My B is going to be -1. My C is going to be a 3. And then my D, in this case, is a 4. All right, so that's what I have. And so there you have it, right? So from the viewpoint, so if I go back in here, I've tilted it up a little bit. Where's my X? Okay, so my X is over here. My Y is over there. Let's see if I can straighten this out a bit. All right, so there it is. I'm actually going to remove the other one because I just find that it's it's a little bit hard to see. So here it is. So here's your X. So notice I'm drawing it out as the way that we did. Notice the 3 points, the intersecting points. So that's exactly how the tool, this 3D plotter, does it as well. So it does the 3 points and then it just extends the plane. So that is pretty neat to be able to see. So within here, that's what you have. And this is how you can actually start plotting, and do understand that this is one particular way of actually trying to plot out planes in 3 dimensions. I've only given you a few examples in here. Of course, you can take on many different examples, and now you should know, okay, how to find the X, the Y, and the Z intercept, if they exist, of course. If they don't exist, you will find that one of the components A, B, or C is going to be 0. So that's what you have in here. Now, to conclude this video, we should kind of think about these particular planes in 3 dimensions. And I want to bring you back when you were thinking about lines, and when you are discussing lines, you know that you really just need 2 points to be able to try to get an equation of a line, right? So from those 2 points, you can find the slope, and then you can find the y-intercept, and you're done. Well, in 3 dimensions, 2 points is not enough, right? 2 points, we can draw a line through those 2 points, but we don't know if it is a plane or not. It turns out that for planes, you need at least 3 points to be able to draw a plane. And those three points, of course, cannot be collinear. Now, collinear means that, they're not in a line. So, if you have 3 points, okay, in a plane, you don't want them to be in a line, because then it's not going to create a plane for us. So they actually have to be non-collinear in some way, right? So that we can create, you can think about in terms of 2 vectors, right? So 2 vectors can be created, starting from 1 point, and then maybe, there's another point over here. Now this, of course, I'm drawing it in the actual plane in here, right? But if you're in 3 dimensions, you can draw this out. And then these 2 vectors can now span out. So this is important to know. You need at least 3 points, and they cannot be collinear. So this cannot happen. And then from those 3 points, we can actually create the equations of a plane. And, I'm going to do that. I'll do videos on that as well. So you can search my channel. But for the time being, okay, I just wanted to be able to point out to you that this is your starting point, and also what the actual standard form for a plane is, or a scalar form for this, which is going to be this particular form. All right, so welcome to this introduction on planes. Okay, I'm going to do more, okay, going into vector representations of planes, parametric representation of planes, and then also doing some examples where we have, 3 points and then how we can find the equations of planes. All right, thanks for watching. We'll see you in a future video. Bye, everybody.